We're looking at the last 2 points of concurrency in a triangle today, and the first one happens by connecting the vertex of each side with the midpoint, the vertex of each angle with the midpoint of the opposite side. So we have from A here to D, we have from B to E, and we have from C to F. And again, the first thing we should notice here is that there's a point of concurrency where those 3 line segments meet. Now, these segments themselves are called the medians of the triangle. So they go from, again, the vertex to the midpoint of the opposite side. In other words, AF is congruent to FB, BD is congruent to DC, and AE is congruent to EC in the triangle. Now, second, again, this point G is called the centroid. So the medians of a triangle meet at the centroid, and this centroid does something special to each of the medians themselves. So we're going to measure them and see what that is. So I'm going to use the median here, AD. So I have A to G and G, and notice that we have a little over 2 for GD and a little over 4 for AG. Now if I move this a little bit, right, I'm going to clean this up, try to make it a little more obvious here. Right, so GD is basically 2, AG is basically 4. So how do those two things relate to each other? Well, it seems like from the centroid to the side of a triangle is half the length of the centroid to the vertex. Or the centroid to the side of the triangle is half of the vertex to the centroid, right? So there's a 1/2 times 2 play here, right? So if I did a different measure, like from B to G, it's 4.2, 4.3. I'm going to change this just a little bit again to 5, right? What would the length of GE be? Well, it would be half of 5, so it would be 2.5, right, or 2.5. And then note that the whole segment is those two things added together. So we'll come back here again. I'm going to just keep changing this. So we have AG is 4, GD is 2, the whole median AD is 6, right? It's just the sum of the two parts. And we'll do one more here. So if I look at the short one here, FG, it's 2.29, right? Or 2.2 basically. So what would GC be? Well, it's going to be twice of that, so it's like 4.46. 4.458. All right, so again, this is the centroid of a triangle. It's made up of the medians, and it divides the segments of the triangle, the medians here, into parts that are half or twice of each other, the longer one being from the median, from the centroid to the vertex. And then the other thing it does is that if you look at the whole, right, AG plus GD is 6, 4 is 2/3 of 6, 2 is 1/3 of 6, and that relationship also works. So there's a 2/3 to 1/3 of the whole segment happening, or a 2 times 2 or times 1/2 over either of the two parts. The centroid that we just had is also called the balancing point of a triangle. So it is where you can balance, if you were to cut the triangle out, you could balance it on that point. and it always happens inside the triangle. All right, the last one we have to look at, this is going to be made up of the altitudes of a triangle. An altitude is through a vertex perpendicular to the opposite side. So this is different than the perpendicular bisector, as it does not have to bisect the other side, right? And the perpendicular bisector does not have to go through the vertex, right? So there are two differences between the two. So if it doesn't tell us that it's bisecting the side, then we wouldn't assume that it is. And we're going to do that with all of them. So these are all altitudes in the triangle, and note that they meet at a single point, and that point is called the orthocenter. And really, that's it. So orthocenter made up of the altitudes, and there's nothing else that's significantly important about the orthocenter.